graphs based on off-life period. What is the off-life period? The time required to complete the off of the reaction. Okay. General relation between off-life and other order of the reactions, that equals to T of 2 power n minus 1 minus 1 by n minus 1 kn a naught power n minus 1. This is the general formula relation between the off-life and other order of the reactions except first order reaction. So the first order reaction is entirely different from other order of the reactions. So the first one is the zero order reaction. So zero order reaction n equals to 0. So the T half equals to 2 power 0 minus 1 minus 1 by, so 0 minus 1 and k naught a naught, that is the 0 minus 1. Here that is the 2 power minus 1. So 2 power minus 1, so that is the 2 comes into the denominator, and this is the minus and minus, so this is the cancel, and the a power minus 1, so the a naught go to the denominator, and finally we get a naught by, that is the 2 k naught. This is the relation between the off-life and initial concentration of the zero order reaction. Now this equation you can write T half equals to, that is the 1 by 2 k naught into a naught. Here this equation in form of y equals to mx form. Now the graph here, that is the on y axis, that is the T half, on x axis, that is the a naught initial concentration. Now the slope here, that is the straight line from the origin, so that is the slope equals to 1 by 2 k naught. So this is the graph related to the zero order reaction of the off-life period. And the next one is for first order reaction. So the first order reaction, so this general formula is not applicable to the first order reaction. So the relation between the off-life equals to 0.693 by K1. So this relation, the off-life is independent on the initial concentration. So the off-life does not affect this initial concentration. So in the off-life equation, there is the no concentration of the reactant. So the graph, that is the y-axis on T off, on x-axis it is the initial concentration. So it does not depends on the initial concentration. So the T off is the parallel to this the initial concentration. So the T off does not affect on this initial concentration. So the T off versus A naught, it is the straight line, it is parallel to the x-axis. So this is the relation of this half-life and initial concentration for the first order reaction. Next, second order reaction. Second order reaction, so that is the n value n equals to 2. So what is the relation? That is the T of equals to 2 power. So that is the n minus 1. That is the 2 minus 1 minus 1 by n minus 1. No, that is the 2 minus 1. That is the kn. That is the k2 a naught. That is the n minus 1. That is the 2 minus 1. So that is the T half equals to, and that is the 2 minus 1, 1. So K2 and the A power 2 minus 1. So this is the 1. So that is the 1 by K2 A naught. So that is the initial concentration. So this equation T half 1 by K2, so that is the into 1 by A naught. So this equation in form of y equals to mx form. So graph on y-axis T half and x-axis 1 by A naught, and here slope that equals to 1 by K2. So this graph related to the second order reaction based on the half-life period. And the next one is third order reaction. So third order reaction n equals to 3. So that's why T half equals to, that is the 2 power 3 minus 1 minus 1 by, that is the 3 minus 1 K3 A naught, that equals to 3 minus 1. So here T half equals to, that is the 3 minus 1 2, 2 power 2 4, 4 minus 1 3, and the 2 minus 1 2, that is the 3 by 2 into, so that is the K3, and that is the 3 minus 1 2, that is the 1 by A naught power 2. So this relation is also y equals to mx form. Now here y-axis T half, on x-axis 1 by A naught power 2, and the slope equals to 3 by 2 K3. So this is the graph related to third order reactions based on the half-life period. So finally, in chemical kinetics, Arrhenius equation is the very important one. So the Arrhenius equation that is the relation k equals to a into e power ea by rt. So here this Arrhenius equation and apply the natural logarithms. So that is the ln k equals to ln a. So that is the e power minus a by rt, that is equals to a by minus a by rt. So this relation represented by the graph, now the ln k equals to ln a minus ea by r into 1 by t. So this relation form of y equals to minus, this is the m and this is the x and this is the c. It equals to y equals to minus mx c. So this relation represented by the graph, so on y-axis that is the ln k and on x-axis that is the 1 by t, and the m is the negative minus, so that's why it is the negative slope, and the slope equals to minus a by r, and the intercept, this is the ln a. So this Arrhenius equation, the graph, the ln k equals to ln a minus a by r into 1 by t. So that is the slope gives minus a by r. A is the activation energy and this is the 1 by t temperature and this is the ln k. So this relation in form of the logarithmic form, that is the log base 10. So this equation 2.303 log base 10 k equals to, that is the 2.303 log base 10 a minus a by r into 1 by t. So this equation divided with 2.3 on both sides. So what happened? So this 2.303 log base 10 k by 2.303 equals to 2.303 log base 10 a by 2.303 minus a by 2.303 r into 1 by t. So these 2.3 are cancelled. So finally we get log base 10 k equals to log base 10 a minus a by 2.303 r into 1 by t. Now this relation y equals to minus m x c. So now graph on y-axis, that is the log k and this is the 1 by t on x-axis. So that is the slope, negative slope. So that's why the slope equals to minus ea by 2.303 r, and here that is the intercept log a. So if log a versus 1 by t, the slope is minus ea by 2.303 r, and the log k versus 1 by t, the slope is minus ea by r. So this is the Arrhenius equation graphs. These are the very important in competitive examinations. So these are the chemical kinetics graphs. So only by the three formulas we can write, that is the more than 20 graphs in chemical kinetics. So they are the, what are these formulas? I can repeat. So first one is the differential rate law, that is the rate equals to kn a power n. So based on this differential rate law, we can draw the graphs for all order of the reactions. So the second one is integrated rate law, that is a naught power 1 minus n, that equals to a 1 minus n minus n minus 1 knt. So this is the differential rate law. This is the integrated rate law. And the third one is, so this integrated rate law is not applicable to first order reaction. So the first order reaction ln a naught by a, that equals to k1t. This is for first order reaction only. Okay. So the fourth one is the t of life period, the 2 power n minus 1 minus 1 by n minus 1 kn and the a naught n minus 1. So this is for the off life period relation. And the fifth one, Arrhenius equation, ln k equals to ln a minus a by r into 1 by t. So in chemical kinetics, from these five equations, we can draw the more than 20, that is approximately 25 graphs from these five formulas. And it is the very important, the graphs in the chemical kinetics. So you follow these five equations, and please subscribe my YouTube channel JBR School of Chemistry for more interesting chemistry videos for CSIR and JEE, NEET and the other competitive examinations. Thank you. Thank you very much.